Hi everyone. So today we are going to start a new topic which is probability. Now probability is very interesting and little tricky topic, but we will make sure that you understand everything what we are going to teach in this particular course. And out of this course you should be able to solve all the questions that has been asked in GATE or in any other examination of that level, which means GATE, ISRO, DRDO, TIFR or other examination of that league. Okay, so let's just get started. Now, like I will be following the book that is referred by MIT. So there is one professor in MIT, and I will be following his book. Now, like most of the times, you don't need to do anything else apart from the lectures. But if you want, then you can just download that book. Okay, that book is also available. The course notes is also available. The lecture notes are also available. So you can download one of them, and then you can just see what is written there. Otherwise, like you don't need to do it. Like just for the sake of completion, I am telling you that I will be following this book for this particular course, because I have found this book to be quite useful. I have followed that book in IISc and I found it to be quite useful. So that's why I will be following the same book. It's very nice and easy book. I mean, it's easy to understand basically. Okay, so let me just clear out the expectations that we will be having in this particular course, or what we will be studying and what will be not studying, right? So what we will study, and this is where what we will not study in this course, what we will not study, right? So in this particular course we are going to study like sample space events, probability definition, and all of these things, which means the basic definitions of probability, axioms of probability, basic definitions of probability, axioms of probability. Okay, axioms of probability. And like we are going to discuss sample space event, these things, sample space events, these things. We are going to discuss Bayes theorem. We are going to discuss probability distributions, like the discrete distribution and continuous distribution. So we are going to discuss random variables, and I can say here we will discuss the probability distributions, right? So these are the things that we are going to discuss. But what are the things that we are not going to study in this particular course of engineering mathematics probability? So we will not study the combinatorics type of probability. Okay, that we will study in discrete mathematics. So I will say that combinatorics type of probability is in discrete mathematics. Okay, so we are not going to study the combinatorics type of probability, but we will study this engineering mathematics related type of probability. So I hope that is clear. The expectations are clear that we will not study P and C. P and C means permutation and combination. Okay, permutation and combination. These are the things that we are not going to study, right? We are going to study the basics of probability, the sample space, the fundamentals of probability, like how it is defined, what are the sample space, what are the events, what is the Bayes theorem, the random variables, probability distribution, and all of these we are going to study. But the combinatorics type of probability we will study in the discrete mathematics. Okay. So without any further delay, let's get started. So probability. What is probability, right? Let's just start with this question. Now suppose that we say the probability of appearing a head on a toss of fair coin is 1 by 2. Then what does this mean to say? Which means I am saying that if you toss a coin, then the probability that there will be a head is 1 by 2. Does this mean that if you toss two times, then you will be getting one time head? No, right? It is not guaranteed. Like if you toss two times, it is not guaranteed that you will be getting one time head. What about four times? If you toss four times, then are you guaranteed to get two times head? Obviously no. Then what does this mean to say that probability is 1 by 2? If this answer is no and this answer is also no, then what does this mean to say that probability is 1 by 2? What about maybe 10 times or maybe 100 times? Are you guaranteed to get 50 times head? No, right? That's also not necessary. So what does it mean to say that we will like the probability is 1 by 2? It means that if you toss enough number of times, okay, so for example, like in past, like people have tossed, actually, like mathematicians are very crazy and they have tossed like physically they have tossed it many times. So one of the mathematician tossed how many times? 4,000 times, and he has found that it is very close to half heads and half tails, which means if you toss two times, then maybe it is not necessary that you will be getting one time head. If you toss four times, then also it is not necessary, actually you will be getting two times head. If you toss 100 times, then also it is not necessary. But I mean, if you toss enough number of times, and what is that enough? It is a theoretical number. So I will tell you the experiments that people have been doing. So one mathematician has tossed 4,000 times. It found that okay, almost half of the times head, half of the times tail. One other mathematician has tossed 24,000 times. He has found that 12,012, these many times heads were appearing and remaining times tails were appearing, which is almost half. One mathematician has tossed 2,000 times. He found out that okay, 996 times head is appearing, which means that if you toss enough number of times, the key is enough number of times, then it is equally likely you will be getting heads or you will be getting tails. Which means I can say that if I am tossing n number of times, and let's suppose the number of times that a head is appearing, okay, is nh, or maybe let me write this. Okay, let's just write nh or something. The nh is the number of times head is appearing, number of times head is appearing, n is total tosses. So this is basically half. But here this n should be large enough. You can't just say in just one or two, maybe not one or two, maybe not 100, 200, maybe not 1,000, 5,000, 10,000, maybe not 1 million, 10 million. Okay, it is just a theoretical number. If you just say that okay, I have tossed 1 million times, still I'm not getting 1 by 2. Maybe let's just toss for 100 million times. Okay, so basically it is just a theoretical number. I will say limit n tends to infinity, which means you toss enough number of times, then you will be getting 1 by 2 times head. That's the theoretical definition of probability. Okay. So otherwise, like in practical sense, as I just showed you the examples, you do not need to toss obviously 1,000 times. Oh, sorry, infinity times. If you just toss maybe 1,000, 2,000 times, then also you will be getting almost 996 times ahead. Like that mathematician has got. And otherwise, like some other people have tossed some other numbers, they have got similar to half of the times heads and half of the times tails. So it means that probability is half, means if you toss it enough number of times, you will get okay, you will get to understand later slowly as the course progress. But for now, understand like this: if you toss enough number of times, you will be getting almost half as head and almost half as tails. Which means probability tells you that how likely an event is to occur. So which means if you're tossing a coin, then it is equally likely that head will occur and tail will occur. Okay. So probability just tells you that how likely an event is to occur, which means the 50%, if the probability is half, then 50% chances are there that you will be getting head, and 50% chances are there that you will be getting tail. Now suppose you toss 100 times and you get head everywhere. Is this possible? Tell me. Is this possible? You toss 100 times, you get heads everywhere, maybe 100 times, and you get head everywhere. Yeah, it is possible, but the probability will be very low. Okay. Yes, it is possible. Like we will do it like probability calculation later, but yet yes, it is possible, but probability is very low. Which means that mathematics doesn't deny it. Okay, mathematics doesn't say that head cannot appear. It's just that there will be very less probability of occurring head like this. Okay, so if you toss it 100 times, then it doesn't mean that 100 times head cannot occur. It just means that it will be having very less probability. And can you tell me the probability, which is 1 upon 2 power 100 probably. If you know that calculation, it is okay. Otherwise, we will calculate it later. Okay. And let's suppose, like I say, that in 100 times, maybe 40 times head occur. Is this possible? And 60 times tail occur? That is also possible, right? Everything is possible. It is just that they will be having different probability. And what is the probability of that? That I will tell you later when we will be studying binomial or binomial distribution, especially the binomial distribution for this case. Okay, so I will tell you later. Like it is basically NCR P power R or something like that. So I will tell you that how to calculate these probabilities later. But for now, understand that if you are tossing 100 times, then 40 times head may occur and 6 times tail may occur. And mathematics doesn't deny anything. It is just that mathematics says that it will be having different probability. If you are having head, and this will be having different probability, like that. Okay, so anything is possible. That's not a problem. So I hope you are getting the meaning of probability. It just tell you that like whenever you are doing some experiment, then how likely an event is to occur. Okay. So don't worry, we are just building the basic foundation. You will get to understand the meaning of probability and everything in this course slowly. Okay. Now let me define a few terms that we will be using here and there. First is sample space. So what we do, we basically perform an experiment, and out of that experiment, there might be multiple outputs. So every probabilistic model involves an underlying process called experiment that will produce exactly one out of the several outcomes, which means there will be experiment, and out of that experiment, we will be producing some output. Let me just show you how. See, suppose you are performing some experiment, and out of this experiment, there are many outputs that are possible. One is this, one is this, one is this, one is this, one is this. For example, like your experiment could be tossing a coin. This is your experiment. This is your experiment. And out of that experiment, how many outcomes are possible? Only two outcomes, head and tail. So you will say that this is your experiment, and out of that experiment, these are your outcomes, which are head and tail. And all possible outcomes are called sample space. Okay, so sample space, if I just go to the definition again, so call the every probabilistic involved. Okay, the set of all possible outcomes is called sample space of the experiment. Which means if I just ask you that what is the sample space for this experiment, then can you tell me in terms of set notation what is the sample space? Head and tail. Why? Because these are all possible outcomes. These are all possible outcomes that you can get. ठीक है, ये समझ में आ रहा है धीरे धीरे, है ना? Like we will have more examples. For now, let me just define 2-3 terms, then we will connect the dots. Okay. So what's going to happen, that you are always be having, you will always be having some experiment with you, and out of that experiment there will be some sample space. Now in that sample space, if you make some sets, which means that there are, let's suppose you are flipping a dice, or maybe tossing a dice. Okay, whatever you want to call it. If you're tossing a dice, then how many outcomes are possible? Maybe 1, 2, 3, 4, 5, 6, like that. Okay, suppose that 6 outcomes are possible if you're tossing a dice. Then out of those six outcomes, what you can do, you can say that, okay, let me make one event out of these two one event, which means event is just a set of outcomes. Okay, a subset of sample space of the set of outcomes that you have is called event. Which means that if these are the two outcomes that I have, 1 and 2, I will call this is an event. Maybe 1, 3 is an event. Maybe 2, 3, 4 is an event. Basically, event is a set. Is a set. Okay, the set or subset, whatever you want to call, set of outcomes. Okay, so this is an event. This is an event. This is an event. Now you are getting the picture that what is happening. Sample space is set of all possible outcomes. So here you might be having all possible outcomes. This is set of all possible outcomes. Set of all possible outcomes. This is what we call sample space. And everything is set. Good thing about the probability theory is that everything will be in the set notation. So this is also set, which means that sample space for the tossing a coin will be head tail. This is a set. For tossing a dice will be 1, 2, 3, 4, 5, 6. Why? Because these are the all possible outcomes. Now, what is an event? Event is some subset of sample space, which means you may call that, okay, out of these three outcomes, I'm making one event. Maybe I'm making one event here. Maybe I can say that, okay, let me define one event like this. Maybe anything. Okay, maybe two from here, two like this. I mean, anything. So some subset of these this sample space or some set of outcomes is called event. Okay. So let's say that this is event 1, maybe this is event 2, maybe this is event 3. Now, there might be different probabilities of the event, which means I may say that event 1 is, let's suppose in this case, I may say that event 1 is 1, 2. Event 2 could be 3, 4, 5. Event 3 could be just 5, like this. Okay. So there might be different probabilities of this event. That's okay. But like event is some set of outcomes. So what is the probability of this event? Like either you get 1 or you get 2. Or like if you know a little bit of the probability, then you can say that the event the probability of this event is 2/6. Probability of event occurring is 2/6 because either 1 occur or 2 occur. What is the probability of this? 3/6. What is the probability of this? 1/6. Like that, there could be different probabilities of the event. That's okay. Equal, unequal, that's okay. But event is some subset of sample space. So generally we denote the sample space by this omega. Now can you tell me how many subsets are possible of this omega? Given a set, if I just ask you how many subsets are possible, then what is your answer? Yes, power set, 2 power n or 2 power omega if I just say. So these many subsets are possible. So for example, for sample space H and T, now I will call all possible events. Okay, are 2 power omega. So which means you may have H as an event, you may have T as an event, you may have HT as an event, and you may have just nothing as an event. Okay, like you can have anything as an event. Now, what is the probability of this event? Maybe you can say 1/2 probability. Probability of this event, I mean, you can say 1/2 probability. Probability of this event could be 1/2. Probability of this event is just 1. Probability of this event is 0 because it is saying that nothing will happen. It is not possible that nothing will happen. So the probability of this event will be 0. So these are all possible events. So event is what? A subset of sample space. Which means if there are 2 power omega sample, so omega subsets are possible, then everything could be an event. This is an event, this is an event, this is an event. Okay. So I will define the probability also, but for now we are defining the sample space and the event. So what is the sample space? You are having an experiment to begin with, and whatever the all possible outcomes is called sample space. And out of those sample space, if you are like generally we are interested to find out the probability of the event, which means I will say that, okay, what is the probability that head and tail will occur, head or tail will occur? What is the probability that these two will occur? Maybe these two will occur. Like that, we are generally interested in the probability of an event. Okay. So let's define the probability. Probability is basically a function that maps an event to 0, 1. Which means you are going to take, this is a function, probability, generally we denote this function as P, and then this is your, what we call it, domain, right? This is your domain and this is your range, which means you are going to take any event and you are going to map this event to 0, 1. Which means if I ask you that what is the probability of this event B, then you will say, okay, let me check it, which means like I will just map this event B probability to 0, 1, and let's suppose it is coming out to be 0.3 or whatever, right? Maybe let's suppose it is coming out to be 0.3, something like this. Okay. And if I ask you what is the probability of this event, which means I will say like the probability of this event is P of A, then I will say maybe it is, let's suppose, 0.1. So this probability is defined over the events. Okay, which means that whatever I'm writing inside this has to be an event. Whatever, okay, wherever in this in this entire course, whenever I write something here, it has to be an event, because this is the definition of probability. Which means, like, currently we will be dealing with some sets. So whatever set I'm writing here, it has to be an event, and generally, like, everything is an event. And when we move to the random variables and these things, then I will be writing p of x equal to 2 or something like this. If you have ever noticed, like, we write p of x equal to 2. Have anyone noticed, like, in case of random variables, there is something called random variable. Obviously, I will talk about this also later, but we just write p of x equal to 2. That has to be also event. So everything is an event. I will tell you in the random variable case that why it is an event. This x equal to t is actually an event. Okay, everything has to be an event. Whatever you are writing inside this probability has to be an event, because that's the definition of probability. Let's have some example, and by that let's just try to understand that what is the sample space, what is an event, and like this. Okay. So these are two properties of sample space, which basically says that list of all possible outcomes. This means that you should be listing all possible outcomes, which means you cannot say the sample space is just head. This is wrong, because you must be having list of all possible outcomes. This is first property. Let me write it. This is properties of sample space. Okay. So you should be writing every possible outcome. That is first property. And second property is that, I mean, this should be collectively exhaustive. Collectively exhaustive means you should be writing every possible outcome. Okay. And the second property is that it should be mutually exclusive, which means that if you are writing some outcomes, then it should not be the case that those outcomes are not mutually exclusive, which means that you cannot write that outcome is head. You can write outcome is head, outcome is tail, like this, but you cannot write that outcome is head, tail, or something like this. I mean, there should not be any overlap in these outcomes. These has to be mutually exclusive, disjoint events. Okay, I will talk about the disjoint events and these things later. But for now, understand, like, if you are tossing a dice, maybe then you can have 1, 2, 3, 4, 5, 6 as an sample space. But along with this, you cannot have 1, 2, because then this will not be a disjoint set. This is one with the 1 and 1, 2 are having something common. You cannot have anything common in sample space. Every of your input, every of your output, okay, whatever is the possible outputs, these has to be disjoint. This and this cannot have anything common. Is this understood to everyone? Now, what is the sample space for tossing a coin? Let's suppose you're tossing a coin and head and tail are two possible outcomes. Then what is the sample space? It is just head, tail. Okay. Now tell me, what is the sample space for tossing tossing coin 2 times? If you're tossing coin 2 times, then what could be the sample space? What are the possibilities? First time head may occur. Second time maybe head occur. Head, tail may occur. Maybe tail, head can occur, and tail can occur, right? So this is the sample space if you're tossing 2 times. Okay. What is the sample space for rolling a dice? If you're rolling a dice, then maybe a sample space could be 1, 2, 3, 4, 5, 6. And generally we represent this by omega. Or, I mean, some people represent with by s also, s equal to like this. I mean, whatever you like, that is fine. Okay. So sometimes we can represent by s, because s is just a sample space, and omega is also one of the notation that people use. Let's have this example. So if the outcome of an experiment consists in determination of the sex of a newborn child, then the sample space could be girl or boy. Okay, if you're determining the gender of the child, then the sample space could be girl or boy. If the outcome of an experiment is the order of finish in a race among the 7 horses having post position 1, 2, 3, 4, 5, 7, then, like, you need to, let's suppose you need to determine that, okay, what is the final order of the horses if they're participating in some race, then you can say that outcome will be 7 factorial permutations of these. Then this is your sample space. So basically sample space is dependent on what you are interested in. Let's suppose here, if you're tossing a coin 2 times, but you are just interested in only the final outcome. Okay. I mean, you're designing an experiment where you does not matter that what has come first, but you are only concerned about whatever is coming last. then what should be the sample space? Just head and tail. Because you are only concerned about the last outcome, which means you are not concerned about the first item. So generally the sample space depends on our interest of experiment outcome also. Okay, what is our interest? So if our interest is final, like our interest is basically, let's suppose that to check that what is the order of all horses, then the sample space will be 7 factorial. If our interest is order of all horses, then 7 factorial permutations. Let's suppose our interest is just knowing that who has come first. Then the sample space will be just 1, 2, 3, 4, 5, 6, 7. Because either one, like one means horse number 1 may have come first, maybe horse number 2, maybe horse number 3, maybe horse number 4, maybe horse number 5, maybe horse number 6, maybe horse number 7. Let's suppose our interest is in knowing first 2 positions. Then what is the sample space? Yeah. So sample space will be 7 into 6. I mean, number of elements in the sample space will be 7 into 6, which means at first one, like at first 2 position, maybe 1 can appear, and then maybe maybe 2, then 1, then maybe 3, 1, then maybe 4, 1, then 5, 1, 6, 1, 7, and similarly then 2, you will be writing 2, 3 like that, right? So 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. So it will be 7 into 6 elements. Okay. So it depends on our interest also, like how we are designing our experiment. Experiment means that what is our final desired thing, and the whole setup is called experiment. Whatever we are doing is just an experiment. Okay. So if the experiment consists of flipping 2 coins, then the sample space consists of the following 4 coins. The outcome will be HH if both coins are head and like that. Okay. So I hope you are getting that what is the sample space. Now we know that what is a sample space, what is an event, and what is the probability. Sample space, event, probability. So can anyone tell me what is the sample space? It is set of all possible outcomes. What is an event? It is some subset of sample space. What is the probability? It is a function that maps an event to 0, 1. Okay. I mean, this is just a mathematical definition, but that's okay. Okay. Now let's head on to axioms of probability. So in the next video, we will start the axioms of probability. That what are the axioms of probability and what we mean by that. So let's just see that in the next video.